So, in the interest of not annoying those people who are in the room already, we'll make a start. So my name is Mal Toner, and again, let me welcome you along to the latest in the Novosco Let's Talk series. This month we'll be talking about software-defined networking. And I don't know if many of you have had much experience with software-defined networking, so this really is a 101 introduction to software-defined networking and some information about what software-defined networking is, what it can offer to your business, that sort of thing. So if we take a quick look at the agenda, during today we're going to be talking really about things like what are the acronyms around software-defined networking. Sometimes that can catch us out. Other things like what does it actually mean to a business or an enterprise to use software-defined networking? What do you have to do to get into a position where you can use software-defined networking? And where should you use software-defined networking? As with everything, this industry starts off by using something in one area and realizes that it is used in other areas. So some of you will have seen recently, why does software-defined networking matter? And what is this new thing that everybody seems to be talking about, which is software-defined wide area networking, or SD-WAN? Finally, we'll take a look today at the main vendor's approach. I'm going to focus on 4 vendors, 2 at the software layer and 2 at the hardware layer, and what their approach to software-defined networking is and what they're offering to the industry sector, why they believe they're the best way to do it, and so forth. We'll then have a little bit of a conclusion section and finish off with some Q&A. So hopefully going to keep you no longer than about 30-35 minutes. I'll try not to ramble on too much, and any questions, please use the GoToMeeting app at the side to raise a question, and I'll try and deal with those as and when we go along. So, software-defined networking, or SDN. So that's the first acronym you're going to come across. The second one that you'll probably have heard me mention already is SD-WAN. And then sort of interlaced between these two are 2 further acronyms, which are NFV and VNF. Those 2 are really interswappable. So let's talk about what do they stand for. So SDN is obviously software-defined networking, and in its most basic principles, software-defined networking is the idea of taking or separating the control plane of your network. So that is what we would normally call configuration, routing, and packet routing data, and rules and policies and security and access control lists, and separating that from the actual data planes, which is the hardware that shifts packets from A to B. SD-WAN really is the idea of loosely applying the concepts of software-defined networking, the control plane, to someone's wide area network. And really that's taking off big styles, especially inside multinational organizations, where they're looking at SD-WAN as an overlay on top of locally bought circuits from different providers. So that might be SSE in the UK or Virgin. It might be Telefonica somewhere in Europe. It might be AT&T over in the States. So you're buying local circuits from local providers and overlaying that with a control plane that gives you something that looks and feels like a old-fashioned multinational international MPLS or VPLS WAN. NFV, or Network Function Virtualization, or Virtual Network Functions, is the idea of taking stuff that we would normally have dedicated appliances sitting on our network doing, like firewalls, like load balancers, and virtualizing that into the software-defined network, either via control planes or data planes or even VMs sitting inside a hypervisor. So those are the acronyms. So SDN, as I've said, is really about taking what was a traditional network where we had devices each running a config and each having rule sets about how it could deal with traffic, and changing that paradigm. It was built out of a clean slate project done by Stanford University as part of a thesis, and the idea was, well, let's take everything we've learned about networking over the last 25, 30, whatever years, and say, if we knew that now, would we do things differently? Basically, the statement was, well, hell yeah, of course we would. You know, networks have grown, their complexity, their scale, their size, their span has grown immensely over the last 25 years. Just think of the internet. And the idea of having each individual switch in a network be responsible for its own configuration and its own reporting. And I know that we had centralized configuration tools and centralized reporting tools, but in truth, each switch had its own config and reporting engine that looked after it. Surely that can be done a better way. And they came up with software-defined networking. And in basics, as I said earlier on, software-defined networking is about the splitting or the disjoining of the control plane and the data plane into two separate layers. So the control layer, which looks after all your network services, so that might be your quality of service, your packet forwarding, your access control lists, your routing information, you know, packet size, all that sort of stuff is held in the control layer. And that can be tightly integrated into the API layer for application layer control for reporting thresholds, service level tracking, capacity tracking. That all sits now in a dedicated centralized controller system. Meanwhile, your devices out in the network effectively become, well, I don't want to say dumb, but automatically configured devices. They still have a certain level of intelligence, but that intelligence is not held on them. It is provided to them by the controller. So we're disjoining the data transfer plane from the control plane. And that really gives us the ability to then do, and this is what sometimes people mean. Software-defined networking is exactly what I've just said, disjoining the two planes. It enables things like orchestration. So it enables people to write orchestration workflows that basically say, if I see this type of traffic, or for example, if I see a VM with this label, this tag, this setup, then these are the network policies that apply to the traffic of that VM. So software-defined networking itself doesn't give you the orchestration layer. You need that level of orchestration, and there are plenty of tools out there that do that for you, but it is what enables that orchestration to work with your network layer, your infrastructure, your data planes. So why does it matter? Well, basically, you know, 6 little facts here. It basically gives you the ability to transition architecture from being device-centric to being network, or even, dare I say, user and application centric. It creates the ability to program the network and respond agile to the network. It enables significant improvements in control and visibility and responses to that control and visibility. So it enables you to do things like react to denial of service attacks or broadcast storms or packet loops. It simplifies the network, and it simplifies expanding the network or growing the network. It facilitates the creation of a services-oriented network. So this is a network that isn't defined just to carry packets, but defined to carry packets that suit a type of service it is running. And more importantly, it increases the agility of changing that. So for example, you may have a large conference center which during the day wants to give some of its benefits of wide area network and, well, even internet bandwidth to the conferencing facility, but retune that towards the guests in the evening. And it makes that very simple. And it establishes a framework to virtualize components of the network. So those are the main reasons why software-defined networking matters. What does it actually mean? Well, if I put it simply, in the old days, your IP address, where you sat on the network, where you got an IP address, what VLAN you were on, what subnet you were on, via routing and access control lists equaled what access you were granted. And I remember 10, 15 years ago, everybody talking about network access control. I want to make sure that no one can walk into my network, plug a cable into an RJ45 socket and suddenly get an IP address. How can I make sure, how can I posture the end device to make sure it gets in? What software-defined networking does is it gives us a mechanism, and let's be clear here, we're talking about a mechanism. We need the tool set sitting on top of that mechanism, but it gives us a mechanism to change that into users and devices and locations put together, postured correctly, equals the access you're granted. So that might be, for example, that a user, the CIO, CEO, CFO of a company, with the corporately owned device, which has got a certificate on it, has got a BitLocker enabled on it, all that sort of stuff, coming from a known location, the corporate LAN, the corporate Wi-Fi, one of our known offices gets access to certain parts of our network. Yeah? Or that may even go as far as access of packets generated from a application to a service are granted. But if the same user using the same device connects to our guest Wi-Fi, which is inherently less secure, that access is denied. So we're really taking software-defined networking to its conclusion here, and we're seeing how software-defined networking is really going to impact our ability to, for want of a better word, microsegment our network in such a way that allows us to gain better control, visibility, and use of that network. So, for example, taking it to a natural conclusion, and I'm not saying this is something you can do now, but you can see where this can go. A user on a corporate device in a good location suddenly has a spurious number of packets going out and trying to hit a series of servers in turn that wouldn't normally be classed as something their applications would do. We can get a software-defined network to react to that and close down their access. Very simply, very quickly, segmenting them out. The example that comes to my head on that is things like WannaCry. So, what about SD-WAN? Well, SD-WAN is simply the idea, and I know I'm saying simply a lot, but SD-WAN is the idea of taking the technology set that we've just talked about and overlaying it not just on a LAN environment, but on a very large-scale carrier-like environment. You know, for a lot of you, the diagram at the bottom here will look familiar. You have a infrastructure which talks about branch offices which use MPLS to get to a data center and other branch offices, and at the same point you might be using different types of technology, whether it's WiMAX, microwave, satellite, 4G, fiber, Ethernet, blah, 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 blah. And in the same point, you also have links out to the internet. You may even have direct links to facilities like Office 365 through ExpressRoute or AWS through Direct Connect. All of those features come together and they make up your underlying physical infrastructure. But when we apply SD-WAN technologies on that, everything starts to look a lot simpler. It starts to look like users connecting to resources. The vagrancies of whether it's going over the internet are now defined, controlled with, and policed inside the SD-WAN. The vagrancies of whether it's going over MPLS or whether that MPLS has fallen back to 4G backup or ADSL or fiber to the cabinet backup are dealt with by the software-defined networking. In truth, all we need to deal with is this idea that branches connect to resources. And that makes our life a lot easier. And it means that when we're actually defining multiple or big wide area networks, we no longer have to think about, right, I'm going to go to BT for this network, or Virgin, or TalkTalk, or SSE. I can go to who's the best supplier in each location and then use my software-defined mojo on top of that to make that look and feel like one homogeneous network that I can control and manage and look after. So let's talk about some vendors' approach here. Yeah, so I've picked out, well, probably 3 vendors you will have expected me to pick out and one that you may not have expected me to pick out. Yeah, so the 4 vendors I'll talk about are VMware, probably the best known hypervisor seller in the world, Microsoft, probably the best known software seller in the world, Cisco, historically the best known network seller in the world, and Huawei. Huawei are the new kid on the block. They do things a little bit differently. They have a slightly different approach. And if anybody gets a chance to look into their technology, I highly recommend it. But, VMware, Microsoft, and Cisco, excuse me, still have a story to tell. So what is their story? Well, for those of you that didn't already know it, VMware's approach is the answer to today's problem in the data center around networking is NSX, their network virtualization technology. NSX is the be-all and end-all. And do you know what? It's a bloody good product. It really is. I'm a great fan of NSX, and it has a really good story to tell in the data center. Unfortunately, that's its limiting factor. It really is a data center or a hypervisor-based tool. And with VMware's announcement in March of this year that they're going to stop supporting third-party virtual switches on their hypervisor, this is a bit of a one pony game. Yeah, the only virtualized SDN switch that you will be able to run on a VMware hypervisor as of the end of that program will be NSX. So whatever you think you need to do in your physical world, you have to make sure if you're going to run VMware as your hypervisor, it works with NSX. So when we talk about a software-defined controller, we're looking for a controller that can control both VMware NSX and maybe Cisco, Huawei, HP, 3Com, Juniper, whatever switches. Yeah, I don't know why I said 3Com. 3Com haven't existed for years. Apologies. The second one we'll talk about is Microsoft. And in Microsoft, for them, it's all about Windows 2016, specifically the hypervisor stack that's in 2016. So you're going to have to be using 2016 Hyper-V here. What we now have in 2016 Hyper-V is a software-defined host agent and virtual switches split across the software-defined plane of 2016. Where it's lacking at the minute is central management. A lot of it is really still PowerShell scripting. Yeah. So you need an orchestration tool sitting on top that can work with PowerShell scripting and will also work with your hardware out there, yeah, your vendor agnostic or whatever you want to call it, OpenFlow maybe, defined stacks. And there's plenty of manufacturers out there these days that are doing data plane only stacks that you can put your OpenFlow operating system onto. The third vendor I'll talk about is Huawei. So Huawei have the most interesting story to tell so far out of the three. These is the first vendor that I'm going to mention that actually do the full breadth. They have the fabric, the physical hardware. They have the controller that sits on top of the physical hardware, and they have the ability currently to reach into each of the stacks, whether that be FusionSphere, VMware, Microsoft Cloud Stack, OpenStack, EasyStack, HP, Elion, Red Hat, whatever, they reach into those. The key thing here is that with VMware's announcement, we need to make sure that Huawei continue to reach into the NSX layer rather than just their own virtualized switches. But, I've seen some really interesting stuff around Huawei where they've talked about, in education with campus Wi-Fi and campus LAN, where we're using posturing on devices to control where they sit on the logical network, irrespective of where they sit in the physical network. The biggest networking player historically in the world has been Cisco. So what's Cisco's take on this? Well, Cisco, they've stopped calling it software-defined networking, and they use two terms now, which is application-centric infrastructure, which is what they call their software-defined network. And a new one that they've added in the last few months has been software-defined access. And I'll talk about that one in a little bit more in a second. But their ACI, the application-centric infrastructure, is really about taking physical networks, which are on Cisco kit, 2000, 7000 series Nexus, taking the hypervisors, Cisco, VMware, Red Hat, although let's be honest, again, I go back to VMware removing support for other manufacturers' virtual switches. So the Nexus 1000V that was is no longer going to be supported in VMware. Taking computing stacks, they've got a really good unified computing stack in UCS. Taking storage, whether that be things like Nutanix in terms of hyperconverged storage, NetApp, Dell EMC. Taking the layer 4 services, they do a lot of work with Fortinet, FortiGate in terms of virtualization. They also support the Citrix NetScalers as either blade or virtual implementations. and putting all of that into a software-defined networking, and at the central point of that, they're putting something called their DNA center to control all that, to allow you to automate, manage, monitor, orchestrate, and control a software-defined network. Now, early days, Cisco were very much about, we know how to do this, we're the boys, we know how to do this, we're going to do it our way, our way, our way. And over the last couple of years, they've been sitting in their corner doing it their way and doing quite well with it. But meanwhile, the rest of the industry has gone to this open flow, open stack type scenario, and they've all standardized. And in the last year or so, we've seen Cisco come back to the party and go, actually, yeah, this open flow probably does have something to say. We probably do want to integrate with it. We probably do want to use it. So they've sort of come around to the more generic way of thinking of that. Recently, they've announced something called the software-defined access, and this is this idea I mentioned earlier on about taking the user and the device and the location and the conditions and using that as posturing to control what they've got access to. So this really is NAC version 2.5, whatever you want to call it, network access control. A lot of people were really excited about this, but really limited as to what you could do. You know, hey, I only want people who are members of my domain and computers that are members of the domain to get onto the network. But how do I know they are a member of the domain if I don't let them on the network to authenticate? And if I've let them on the network to authenticate, at that point they've got an IP address. So how do I do that? So you get this idea that, well, hold on, he hasn't authenticated to the domain yet, so I'm going to give him an IP address, but I'll use my software-defined networking to make sure the only thing he can do is send packets to the domain controller for authentication. And if they don't look like authentication packets, I'll cut them off there and then. And he or she won't get access to my network. And straight away, I've increased security of my network. So you can see where software-defined network is going. And when you start to think about the Internet of Things, IoT, this idea that everything in our house is going to be wirelessly enabled, you know, this idea of software-defined networking becomes really important for us. Because if I've got a device sitting on someone's Wi-Fi that they've forgot to put a hardened security password on, and that's the same Wi-Fi that they connect their corporate device to when they're working from home, that's a worry to me as a business. So this idea of understanding that, understanding what we're seeing and reacting to it becomes very important. So as I said, it's short and sweet today. We're going to talk about conclusions. Let's say it's not just about software-defined networking, that's a really good buzzword, but orchestration and standardization are key here. Whatever we need to do, we need to think about how we're going to take advantage of these tool sets, how we're going to allow our DevOps people to be able to define VMs, services, Docker applets, whatever we want to call them, with tags that control the orchestration and the standardization of our network. And as a result, it's no longer just about the VM, it's no longer about an entity that has an IP address. It can be about the services that are running on that. It can be about the events that are happening to that. It can be about the circumstances around that machine. This idea of seeing a machine that's doing something that it normally doesn't do and reporting that into software-defined networking that may either make a decision or at least inform us and ask us to make a decision about cutting that service, him, her, user, whatever, off at the knees. And it's no longer just about the local area network. It's about the user device. It's about the user themselves. It's about the location. It's about the circumstances. It could even be about the day of time, day of week, time of day of week, all those items, All of this goes together to make software-defined networking one of the biggest paradigm shifts we've seen in not just network management, but network security and network control. So hopefully I've whet your appetite. There's loads of things out there, just do a YouTube search on software-defined networking. There's some really good videos out there. I'd recommend that you limit your search to the last year. There has been a massive shift in the way this technology has been used in the last 18 to 24 months. So you want to keep current, look at stuff that's given you results from the last year. So thank you very much for your time. I hope I haven't bored you too much. I hope you've whetted your appetites. If any of you do want to get in contact, I've forgotten to put my email address up there, but my email address is mal, M-A-L, .toner, T-O-N-E-R, at Novosco, Novosco.com. Any questions, please feel free to use the question pane to ask them. I'll be around for the next couple of minutes. Hi there. So you just cited Dell. Do you think it could be a player as well, using what they're calling the open network? Absolutely, Dell. I didn't want to go into everybody, but Dell, and I mentioned Dell EMC mainly because that big acquisition. They're one of the biggest hardware players now in the world, and with their open networking stuff, they are a player as well. I think the key thing here is to look at the standards that all these different manufacturers are using. OpenFlow being the most pertinent one, and look at the technologies they're using. When it comes into NVF or NFV, the network function virtualization, look at what they can do. For example, with your Cisco solution, they've really relied a lot on the information coming from Citrix with their network load balancing to do that sort of stuff for them. Yeah, they obviously have their ASAs and their firewires and stuff like that for the security, but they're also partnering with people like Fortinet. So yes, Dell is someone to look at. Not discounting them at all, but in another respect, they're historically their networking has been seen as an SME solution, not an enterprise solution. I may be wrong on that, but that's my view. Any other questions? Okay, thank you very much, guys. Hope you enjoy the rest of your day, and have a lovely summer. Cheers.